So this is the code review session. Here we're gonna see what are the codes of all the microservices. I mean actuator, switches, client, coupler, and communication framework. So let's walk through the communication framework first. This is the main class, and all of these objects will be used by the test classes, so I just kept it here. So the main thing here is subscribe. Here you can see this is the subscribe class, which just takes us simple string. So before it was a fixed topics related on our microservices. Now I changed it to a general string which can be used by any microservice. So there is some add, subscription, remove, just to check if topic is existed, and just to clear all of the topics. And here in the identity we have MS identifier, which is used by every microservices to identify itself. Before it was a address used to be a VPN port, so I just kept this micro MS identifier, but later in the phase it was not needed, but I didn't eliminate it. Maybe we will need it. So this is the messages. Here you can see it will have UID, correlated IT, topic, which is a general listing from the subscribe, timestamp when it was created, origin of the microservice, and its payload. The payload will be a object class, so it can contain any kind of payload from different objects. Here we have message channel, which is a receiver and which is a sender. This receiver is always open to receive any messages which is broadcasted by other microservices. If it is connected to that microservices, it will receive the message, and after receiving message, it will keep the message in the queue. So here we have sockets, here we have bytes, and all the messages receiving logics. How it gonna receive message? I just print it to make sure the message is received correctly, and it receives and place the message in the queue. So there are some helpful functions associated with this receiver. Here this is the sender, which will have a queue of the messages which is needed to be sent, and it has a list of the microservices which are connected to this microservices. So it will go through the loop and broadcast all of the messages which is in the queue to the microservices it is connected to. So whenever there is a message in this queue, the message will be broadcasted, and the message in this queue will be kept by the microservices itself. So there are some helpful functions for the senders. So this is the main message handler. It is the maskler, which is used to convert the messages to the byte array. So here we have handled the error case by just returning null. When some error message arrives, it will just return null, and same is to convert from the byte array to the message objects. So if something happens, null will be returned, otherwise it will convert to the byte array and send back that byte array. This is the message creator, which is used to create message by taking payload, topic, and origin of the message, and it will just simply create a message. This is message handler. This will receive the message which was kept in the message receiver. Here you can see phase message from message receiver. So this function will receive the message which is placed in this message. So it is like a pullback functionality. So if the message is not null, or if the message is not error in our case, then the message will be placed in this queue, not this queue. Yeah, this queue. So this queue is for checking purpose if the message already arrived or not. If the message is already arrived, then the message will not be kept in the queue. So is message already received message? There is a function to check it. Here we check the functionality if the message is already received. So this is for the purpose of preventing the loop cases. And here is the subscribe message handler. this here only the message will be arrived which are subscribed by this microservices. So subscribe we have to initialize and inject in this class. So there is a subscribe class and objects, and it will receive the message here and place it here. So fetch message from message handler and 8. It means it will fetch the message, and if the message is not null, then it will keep in the messages. So from here on, I'll go to the actuator. I'll just show one actuator how it's gonna work. So this is the sender and receiver of the actuator. So the receiver has to be initialized. So these are the objects which is used from the communication framework in this microservice. To initialize the communication framework, we have to initialize subscribe, we have to initialize the message receiver, we have to initialize the message handler, we have to initialize subscribe message handler. So what all of these will run in separate thread. So message receiver has thread, this will have own thread, this will have its own thread, and fetch message from communication framework will have own thread. So this will run in Actuator. It will run all the time. So whenever message is not null, it will just receive the message from the communication framework. Same with the subscribe handler. When the message is arrived in the subscribe message handler, when there is message inside the subscribe message handler, it will receive the message. And it's the same with this case as well. And you start receiving broadcaster message. It means it will message receiver is activated here, and it will run because the thread is run method is initialized inside the message receiver itself. So whenever it we initialize and start from here, then here, then the run method will start in the message receiver inside communication framework. So this is for message receiving, this is for sending messages. In this actuator has two type of messages. One is relay message, one is reply messages. So whenever it receives message from switch, it will give a relay state and reply as well as reply for the purpose of learning phase to the network coupler. It will send back the reply message. So here you can see we initialize them connected microservice for sender, start sending message, then message sender, which is from the communication framework, add message for sending, and then we'll create a new message and just add the message. From there on, message sender from communication framework will just broadcast to the microservices which is connected to it. So whenever message is received in this microservices, this parser will fetch the message from there, fetch message from receiver. It will always fetch message and keep in this received message. This received message is just to view on our endpoints how many messages and which messages are received. So this is this will receive switch message all the time only. So these microservices will just use JSON to convert the string object to the class objects, and after parsing it will keep messages here. From here, executioner will fetch the message from there as well. Yeah, executioner will fetch the message here and parser.poll message, and if the message is intended for this microservice, it will execute the message, it will send relay states back, and if the message is not from the same group, then it will send acceptance reply. and if the message is not intended for this microservice, it will just send the rejection message if the message is not from the same group. So if the message is from the same groups, it will not send the reply, because network coupler don't need to know if the message should be passed or not if the messages are from the same groups. So this is for send relay states. This is for checking if is intended for this microservice and is not from same group. And this is for executing and changing the relay states. This is for sending the acceptance reply. This is for sending the rejection reply. So it will just send the same message but just changing true and false as acceptance and rejection. So the message types are relay state, switch states. There is controller for viewing the state of relay and messages which is arrived here. This is actuator initializer. It will initialize the actuators and it states at false, and it will initialize as well as the buttons which it is connected to from the config file from this file. So there is a connected button first, connected button second, and its ID, its group ID, all those things information is mentioned in this config file. So this is the connected microservices to this microservices which is initialized at the first. And this is actuator, which is an entity like a model. This is relay. It will have ID, state, connected button, first and second. So this is the actuator. Now we'll move on to microservice switch first, then we'll move to couple. So we have here client, which will communicate with the switch through RMI interface. So this is RMI communicating to the client. So the port is 6001 for this one with the local registry, and it will bind the client method here. So client will communicate using the RMI, and this is do while loop, which is used for command line interface. And whenever message is received here in this switch, there is a client message receiver class in this sender and receiver. It will use to create a message from that button ID. So if the message is from some button ID, it will get your button ID, group ID, and connected actuator ID, all those things, information which is needed. So there are three types of receiver in this switch. One is from client, one is from microservice, and one is for sending the message. This sender and the sender from the actuator are same. This receiver and receiver from the actuator are same. So these two class has to be initialized first for all of the microservices to receive and to send the message, and all of the activities after that is individual to the microservices. So this is the client message receiver. It will receive it will use to create a message. These are all the information of the buttons, and it will create from which button, from which switch ID, to which group, to which actuator ID, to which relay ID, and what is the state to be sent. So the state will be calculated in the switch itself and sent to the actuator to keep the switch in that state. So this is for sending message. This will send message to the sender. This sender will send message to the message sender of communication framework. And this is the same as 4 threads: subscribe, message receiver, message handler, and subscribe message. which was almost copy and pasted from the actuator for all of the microservices in this case. And here is parser, which will parse the message, which will parse the messages from the relay state messages. So it will be relay messages, it will parse it and keep it here. This is executioner, it will execute the message which was received. This is the message, relay message, switch message. This is the logic component, but I have not implemented how you wanted, but at least I try to implement it, like to get the relay states and to calculate what state should it send back. So it will calculate and just keep the opposite of what the relay state is. It is in current time, because whenever a message is received from some switch, the actuator will reply it, and all of the microservices will get the message and put the current state of the actuator. So it just send opposite of that. These message relay states, these buttons, switch, like just entity. I think this is the important class here. This is process message, execute message. Yeah, this is basic switch. Yeah, so let's move on to the coupler. Here we'll see the main thing, coupler, which sits between two microservices. This is coupler. This is for configuration file. All of the microservices have their configuration file and initialize their states and all those things. So it is connected to which port it is running on, all those things, and how many connected microservices, how many of same group, all this information are mentioned here. This coupler. Receiver, same as other microservices. Sender, same as other microservices, but only the difference things is whenever message is from one group, it will send message to other groups. It will not just reply message to the same group. So we have two groups and we make it based on that. So whenever message is arrived from group 1, it will send message, broadcast message to group 2, not group 1. So if message is from group 2, it will broadcast message to group 1. So it's a bit different from the other microservices. And here there are parser, same as other microservices. Here is the parser which will parse message. It will get two type of message: switch message and reply message. This reply message is only intended for the coupler, so this message is the main point where the coupler will be in a learning phase based on this message payload. So fetch message from receiver. After fetching the message, there is some error, maybe messages. Yeah. This will process the message. When the message is switch message, it analyzes the acceptance size. Rejection size is 16, then it will not forward the message. Forward message without filter if it's less than 16. If it's 16, the learning phase is over, then it will forward the message after the filter. So here it will analyze messages 1. If it's less than 16, it will go for the analyze messages. So here is the analyzing. If request message that it accepted, then it will add message to add to accepted messages. If it is rejected message, it will place the message in the rejection list. So whenever after the filter is activated, learning phase is over, then this network coupler will analyze if each accepted message reply message sender A to send message. If the message is accepted message, then the message will be forwarded, otherwise it will be just ignored by this communication framework. So this is the basic main logic for sending the message to the other microservices after learning phase is over. So this is the analyzer. This is for adding. This is for adding to rejection list, and here we are checking if the message is already existed or not. Here is accepted message, which is used for filter. And here one more thing, construct. Okay, analyze message, forward without filter. It will just forward without filter. It forward after filter. So when the message is from relay, it will just forward. It will not filter any relay messages. So this is basic types. It will have reply messages, it will have switch messages, it will have connected microservices. So there are two separate groups here list. As I told you earlier, if my message is from group 1, it will broadcast to group 2, not again to the group 1. And this is network communicator initiator. And yeah, this is for viewing the message which was accepted, which was rejected. Here you can view, as I showed in previous video, how you can do it. So this is the basic setup. And one more thing I forgot to mention was this analyzer was missing in the GitLab in my case, as I have to do it manually again. And all the problems which I faced during the build phase was this config file was not placed it properly when I placed it here inside the main folder. So I have to move it to resource folder and has to do a little bit of different configuration. And yeah, this is the basic thing. The build was not working properly. And one more important thing which I find during you running it from terminal is that this has been applied. I just applied it, so this was applied by me. If we use this case, whenever we want to pull message from this link list, the message was aired in the switch messages, but this poll was not receiving any messages when I run it from the terminal. I don't know what was the problem. Maybe the thread was running very fast and it could not fetch any messages from there. But whenever I run it from IDE, it was working fine. But whenever I try it from terminal, sometimes it works, sometimes it was not working. And when I place some wait of 1 second, then it start to work. Since everything was not in GitLab, so I do not try to change everything. Just for the information I tell you all these things. If it's not working in your case, yeah, this is the basic setup. And thank you for listening. Everything. Yeah, bye. Thank you.